series on programming in Java problem solving approach. So today we are diving into a question that's very fundamental to our journey. Why is learning a program important for everyone? So if you see here, there are other related questions also. So number one is why programming is essential in today's world. Then we can have a question like this also. What role does a programming play in solving a real world problems? I'm talking about real world problems. And then what should we learn, or why should we learn programming, and what impact does it have? But uh, all the questions are basically lying on this first question itself. Why is learning program important for everyone? And to answer this question, see, programming is not just for computer science majors or tech enthusiasts. In today's world, learning to program can open doors to numerous opportunities. It enhances problem solving skills, and it gives a deeper understanding of how technology shapes our lives. Whenever you are looking to boost your career, this is the another way that you can see. Whenever you are looking to upgrade, to boost your career, you develop a new hobby or simply understanding the technology around you. So programming offers a valuable skills that are increasingly in demand across all fields. So in this video we'll explore why learning Java, one of the most versatile and widely used programming language. And when I'm saying it, so I mean it, one of the most versatile and widely used programming language, can be a game changer. So let's get started and uncover why programming is vital skill for everyone in today's digital world. And to answer this, see, when you are learning a program, or when you are learning a coding, and when you are learning a problem solving ability in computer science, so not learning you are not basically learning a problem solving skill in computer science, but also you are learning the real time problem solving skill. So that's the main important thing, problem solving skills. And if you add one more thing on this, because when you are learning program, your critical thinking ability is also improving, critical thinking ability. So this first point, if you put it with second point, problem solving skills plus critical uh, a thinking, so it will give you an ability to create solutions, and that is going to shape the future. And this is a very philosophical thing that I'm talking about right now. But just uh, consider 2 points. You are learning two things at a time: problem solving ability in real life, not only in computer science, you are learning in real life. Plus, you are also learning critical thinking ability, and that is going to create a solution, and that solution is going to shape the future. So, to start with, because this is a very elementary class on Java, so to start with, first we'll go the Java language constructs. So this what constructs, actually these are the fundamentals of any programming language. And to ease this, we have divided into 10 unique topics, and every topic we'll go some in a very slow way, so that each bit and byte you can understand, and some in a moderate pace, so that you can learn and you still are not going to bore, and you are taking something from these topics. So the language constructs we have divided into 10 different headings. So let's start with identifier and keyword. And we will also cover variables and constants in, especially in Java. And the third thing is the data type. This is the most crucial a topic in this slide. And then literals also, and then typecasting and conversion of data type, in between or among the data types, then there is one more important topic, which is the operators in Java. So first important topic is data type, second important topic is operator, and the third important topic is control flow. This is the third important topic that we are going to see. Then in this control flow, obviously students, you are going to see if, and you are also going to see else. If else, I mean a conditional statements. And then the second thing we are going to see in a flow statements is looping. And the last part that we are going to start is string handling basics. So one by one we are starting this, and just to make sure uh, things are working fine, I have opened slide for the identifier. So and for these topics, like for examples, you see these are the 10 things. So some of the topics are joined, and why they have joined, because they are related. For examples, identifiers and keywords. And for each topic, we try to put it a simple definition as much as possible. So we start with identifiers are the names given to variables, number one, number two, methods, and number three, classes or any other user defined items in Java. For example, in later classes, you will also learn packages. So packages, when you're giving a name to a packages, that will also identified by something, and that is called identifier. So identifier is nothing but it's a name given to either of these things: variables, methods, or classes, or even a user defined functions or any user defined items in Java. So here, this is the example that we have taken: integer age. So what is an identifier here? The identifier here is age, which is identifying some integer value. Okay, which is identifying some integer value. Another thing you can have is like add function. Okay, add function. So if you have a function like this, so in this case, add will become what? Identifier. And if you have a class like this, class, let's say circle. Okay, so class circle, and you have the body of this class, then this circle will become what? Identifier. Identifier of what? A class. Then you can have a package also. Okay, package also. So package, let's say my collection. So my collection, in this case, it will become what? A identifier. So identifier is a name given to a variable, method, classes, or any other user defined items in Java. Then we have the keywords. Why we have put these two things together, you will understand and you will come to know. So keywords are the reserved words in Java. All the programming languages are having some keywords. So brief introduction we have already seen for C and C++. We have already seen one script for Python also, and we have seen one script of JavaScript also. So all of these languages, they are having certain kind of keywords, and these keywords are reserved reserved words. Meaning is that once you are defining the identifier, or if you are defining the identifier, you cannot take those identifier as keywords. For example, what I'm trying to say here, let's say you are defining integer, so you cannot call your integer either if, because if as a keyword, or even for. So you cannot have an integer with the name for or with the identifier for, because it's a keyword. So you cannot have this. Similarly, you cannot have a class, or even you cannot have, there are many other keywords also. For example, public, private, protected, all of these are the keywords. So this is about keyword. Then keywords and identifier, they are always you can say they are always taught at the same time, because when you are making identifier, you cannot make identifier with keyword. And variables. Okay, variables, and we are learning constants together. What are variables, kids? So variables are named storage location in memory that hold data which can be changed during program execution. So similar example we have taken in this also for defining the variable. What is a variable here? Here score is a variable. Score is a variable. and the value of a score here, it is 95. So it may happen that this value score variable, after some time it will become 100, or it may become 95 also, or it may become, at some point of a time, 101 also, or it may become 50 also, or it may become 0 also, because it is in execution, it is changing, that's why the name is variable, because it is varying. At any point of time you can change the value according to your need, that's why it is variable. On the other hand, we have something called constant. So once you have declared the constant, you cannot change it. So right now it is 100, but after some time if you want 101, it is not permissible. Why? Because this thing is constant, so throughout the program execution it will remain constant. So these two things are also supplement to each other. One thing is called variable, and another thing is called constant. And the way that we define a constant, so we add one keyword. Again, this is a keyword. So final, we are using this keyword final, and if you write anything final in after this variable name, it will become constant. For example, integer pi. Okay, integer pi is equal to 3.14. So throughout the program it is going to remain same, 3.14. Then we have data types. Okay, our third heading is data type, and this is the heading in which we are going to spend most of our time in elementary things. So uh, to start with the definition, it specify the kind of a data a variable can hold. Yes. So again, the same example I'm continuing with integer. Data type here, age is not a data type. What is age? Age here is a variable name. Variable. It is not a constant, it is a variable name. But what about the integer? It is defining the type of variable. Yes, it is defining the type of variable. What value it can hold in integer. For example, if you are writing age, so what kind of a value? If you are going to store, let's say, uh, 3.15, 3.15. So 3.15 is not integer, it is something else. It is basically double. Okay, this is different data type. It is with decimal number. So data types are very important in every programming language. Uh, it plays a crucial role, and every programming language gives us set of predefined data types so that we can start our program. Yes. And if you want, you can further divide the data types into two parts. One is called a primitive data type, and another is called a reference data type. So for primitive data type, the basic idea here, it is given by the language itself, or you can say it is given by the language compilers. So here in case of a Java, we have already seen one is integer, another is floating point numbers, and you can have a characters also. Then you have the reference data types. So what is the reference data types? They are refer to objects, because Java is object oriented programming language, and they are defined by this concept of classes. And one example that we are taking here is string, and another that we are taking here is arrays. So string is a reference type, and array is also a reference type. Yes, at this point I think this information is sufficient. Data types which can hold some kind of a variable. Yes, that's the definition of data type. There are two ways. One is the primitive, and another is what? Reference data type. Yes, and this topic is so huge. Throughout the series, you will, every now and then you will be hearing about primitive data type, you will be hearing about reference data type, you will be hearing conversion between or among the data types, and you will be hearing where this object is going to store, where this a primitive data type is going to store, how much memory it is going to take. So this all of these things come under this topic of data types. So this topic is huge, and it will go as our series go. This topic will also go. One last thing that we are going to see in today's video is literals. So literals are fixed values directly written into the code that represents or that represent specific data, such as one thing is number, characters, or string. Yes, so don't confuse. I'm always taking a same example, but just to give you a clear cut understanding. Here, in this case, age is what? A variable. Integer is what? A data type. Then where is the literal, students? So literal here is this 30. It's not a value I'm talking about. Okay, I'm not talking about a value because 30 is a value also, and 30 here is a literal also. Literal in other words, you can think whenever the compiler will see, it will come to know that specific data type they are talking about. Okay, one more example I'll give you here. Count is 100. So what is the literal here? Literal here is 100. The value is also 100, but the literal is also 100, and the literal is called integer literal. Then please give me a second example so that I can understand the difference between a value and the literal. So here is the second example: floating point literals. Floating point literals. Here, this price is a variable. This double is a data type. Then 19.99 is a value. Then where is a literal? Literal is this dot basically. Do you see here? What do you see here? The dot. Because this dot is telling that okay, this number is floating point, and this literal type is what? Floating point literal. So whenever the compiler will see a number as a whole, for example 19, it will store in some integer variable. And whenever the compiler will see a number with floating point or a number with point, it will take it as a floating point literal. Uh, I hope this is going in a right direction. Then we have another example, which is of character literal. So here you are defining a data type character. This is a variable name, and this is literal. And what is the value, by the way? The value is a only. Okay, the literal is what? This single quote. Yes, so the single quote is a literal, and the value is a. One more last example to understand a literal, and hope everybody will understand. Everybody will have a clear good idea about the literals. If I'm taking a different data type, which is a reference data type string, then this is a variable name, and this is a value. This is a value. What is the value? Value is a word. But what about literal? Literal is double quote. Double quote. So just to remind you one last time about the literals, if you are giving 3, okay, it is what? Integer literal. And if you are giving 3.0, it is floating point literal. All the values are same that I'm taking here. And if you are taking 3 with single quote, it is what? Character literal. And if you are taking 3 with double quote, it is what? A string literal. All the values are same, but this is integer, this is floating point, this is character, and this is what? A string. Why we are giving these kind of things? Because compiler will understand just by looking at the value. Okay, this double quote, they are talking about a string. That's the representation of a string. Single quote, they are talking about what? Characters. Points, they're talking about floating point numbers. That's the thing that they are giving. I hope these small things they have understood at your end. Just to practice, we are putting a one question here, and the question is pretty simple because our series is based on problem solving ability. So the first question, the first programming question that you are looking here is this. So we have to write a Java program that is going to calculate the area and the perimeter of a circle, and whatever the program you will write, you have to use these identifier variables, constants, data types, and literals. Or in other words, you can say that okay, you have to identify or you have to demonstrate the following 5 things in your program. So let me start with the program. And to start with the program, I have already opened a Visual Studio, and I'm just opening this Visual Studio so that all of you can see that. It's opening. Yes. Oh, here it is, our screen, of Visual Studio. So we have already understood that every program in Java, it starts with a class. So our class name is what? Circle calculation. Then this main function is the starting point of the program, and it is going to be called by the JVM. So once you compile this program and everything is okay, it will become a .class file. And once you try to run this .class file, the main entry point is this main function. So let's start the code quickly. And remember, we are going to compute the area and the parameter of our circle. Okay, so let's start with, to start with, I would write like this: pi. First define a data type double, and then pi, and here I'm writing 3.14. Yeah, it's right. Yes, at this point this is right, no problem at this point. Yes, but see, if you are not making it a constant, some other person will come and he will write like this: pi is equal to 4.12, because he has forgotten the value of pi. And everybody knows that the value of the pi is 3.14, but I mean, he has some confusion and he forgot the value. Now he's writing that 4.12. So the value has been changed. So what we want is, we want to set this value to be a constant value. To make it a constant, just we have to use the word final. Whenever you are making this word final, nobody else can change this value. Now if you're trying to write like this, 4.12, okay, so immediately it will raise an error, and it would say that this is final value and it cannot be changed. It cannot be changed. Yes, I hope the concept of this constant is clear with this program. Now what I'm defining here, student, is one thing called radius. And for radius, I'm just taking an integer value and I'm calling it radius. And this is here at this point I'm taking integer radius is equal to 5. Yes. Then the third statement is where the actual computation starts. Yes, where the actual computation starts. So we are defining the area, and the area, the type of data should be double. Why? Because it is going to store some value which is a floating point number. So I'm defining area, and area is, you know, that it is pi r square. Pi r square. So what I would write here, pi and multiplied by radius. Okay, multiplied by radius, and again multiplied by radius. So this value is going to store, this is the expression. So this value is going to store in a variable called area. Similarly, you can define uh, parameter also. And again, for parameter, you are going to take double only. So double pari. Yes, and this is, everybody knows that it is 2, uh, 2 into pi r. Okay, so what is pi? Pi is pi here in this case, because we have done this as a constant, and radius is radius. This way we have calculated the area and we have calculated the parameter also. So for printing, you know that the output statement, we are using a class system, and we are using out, and then we are using one function called println. Println, and here we are writing like this: the area of circle is, and here I'm concatenating what? Area. Here I'm concatenating the area. Now I just quickly copy this statement once again, and instead of area I would write parameter, and instead of this I would write parameter variable. So this is string, it will concatenate with what? Area, and it will concatenate with what? Parameter. To see the output, you have to run this, and you can see that the area of a circle is 78.5 and parameter of a circle is 31.400. Yes. So uh, we have done a lot, and we have learned 5 to 7 important things. Let's quickly figure out all those things. Okay, remember the question was, we have to identify the identifier, we have to identify the variables, the keyword,